Let's look at some of these double replacement reactions and see how to write the equations, the complete ionic equation, and then the net ionic equation. We're going to take a look at this first one. Is lead nitrate in aqueous solution plus sulfuric acid in an aqueous solution yields lead sulfate solid and nitric acid in an aqueous solution. The first step is to write the balanced equation. So we have lead nitrate sulfuric acid, lead sulfate is a solid, and nitric acid. So we just have to balance this. We're going to put a 2 here, and that should balance us off. Now, we're going to separate the ions because it's in the club. It's club aqueous, right? So it's in aqueous. So the ions get separated. So we have lead 2 ion, it's a Q, plus 2 nitrate ions. Nitrate is -1, plus 2 hydrogen ions. Each hydrogen is +1, and 1 sulfate ion. Yields. Now, it's a solid. When it's a solid, it does not separate. It's insoluble in water. So it's no longer soluble. They're no longer dissociated. And then we have 2 hydrogen ions. And don't forget, this 2 actually goes to both, the nitrate and the hydrogen. So we have 2 nitrate ions. And what we're going to do is we're going to look at the one that changed. This one became a solid. So this is what the one we're going to use for our net ionic. So writing all the ions makes it a complete ionic. So this is a complete ionic equation. Now we're going to want to write the net ionic equation. So we start with the solid. And then we say to ourselves, what 2 things went into making that? Well, we know that the sulfate ion, forgot to put the charge there, made lead 2 sulfate, and we know that the lead made that. So we have the net ionic equation includes all the species that go into making the final product. And the final product is lead 2 sulfate. That's the final product, right? That's the one that precipitated out. Now let's go ahead and try another one. We're going to go and do B. So we have lead acetate. Anything that has the acetate is probably going to be aqueous. This one is aqueous. Plus hydrochloric acid, also aqueous, yields lead chloride, solid, plus acetic acid. First thing we want to do is balance this. So I'm going to put a 2 here and a 2 here. And now we have it balanced because we have 2 chlorine, 2 chlorine. We have 2 acetates, 2 acetates, and we have 2 hydrogens and 2 hydrogens. So we're completely balanced. The next step is to write the complete ionic. So we're going to write all the ions. We have lead 2 again, so it's 2 plus aqueous, plus 2 acetates, aqueous, plus 2 hydrogen, aqueous, plus 2 chlorine aqueous. Yields. This is a solid. If it's a solid, it doesn't get split up anymore, so we have to write this together because it's a solid. It's not going to be, it's going to precipitate out. And then 2 hydrogen ions, aqueous, and 2 acetate, aqueous. So after we're done writing the complete, so this one's the complete ionic, we're going to write the net ionic. So the net ionic includes only those that take place in the reaction. So we start out with the solid that we made, and we ask ourselves, what makes that solid? Well, we know we have 2 chlorine ions making that solid, and we have 1 lead ion making that solid. So this is the net ionic equation. That's the final one. That's the one we use to determine all our quantitative values to see what's happening in the situation. All right, I think we have time for one more. So we're going to do one more. We'll go ahead and do C. With C, we have sodium phosphate. It's aqueous. We have iron 3 chloride, aqueous, forming sodium chloride, aqueous, plus iron 3 phosphate, solid. The first thing we want to do is balance the equation. So we see that we have 3 chlorine here, so we need a 3 out front here. Now we have 3 sodium and 3 sodium. 1 phosphate, 1 phosphate, 1 iron, 1 iron. We're balanced. We don't have to do any more. The next thing we want to do is write them as ions. If they're in aqueous, they're ionic. Remember I told you we're going to call it club aqueous, where water is the solvent. And when you're at the club and you're not married, you get to dance with whoever you want to. So these ions are in aqueous, they're dissolved, they're dissociated. They're not going to stay with together. They're going to go with the water. So we have 3 sodium ions. We have 1 phosphate ion. That's got a -3 charge. That's why we needed the 3 sodium. We have 1 iron with a 3+ charge. And this is why we needed 3 chlorines. Then we get to this side and we see sodium is still aqueous. So sodium is written apart, and we have 3 chlorine ions. And then we're left with iron 3 phosphate, which is the solid. Now, let's go ahead and identify our spectator ions, just in case I ask you that. The spectator ion is the one that's the same before and after. So here we see the sodium is the same before and after, so we can cross sodium out. Then chlorine is the same before and after, so we can cross sodium off. So our net ionic are going to be those that are left. So we have a phosphate ion, aqueous. We have an iron ion, aqueous, to form iron 3 phosphate, solid. So either way, you can do it either way. You can identify the one that's the solid and then work backwards to the 2 ions that make it, or you can cross off the spectators. However you want to do that, and write your net ionic. But just be able to identify which one is the spectator and which one is actually getting involved in the reaction. There we go. All right, I hope this helps, and if you need any more practice, come and see me, and I will help you.